Good morning. Welcome back to the Design for Environment lecture in the course Advanced Green Manufacturing Systems. In this lecture, we will discuss the implementation strategy for Design for Environment. So, this is one of the methodology to implement Design for Environment, which is developed by Fitzgerald. This research was done by this person in 2007. And as I discussed in the previous lecture, the safety review process and environment review process has to go hand in hand. They worked on the stage gate process. There are 8 stages, and at each stage when the work is complete, there is a gate to exit. This is a phenomena that works on working in stages and specific steps. So, there were 8 stages, and these are the stages where safety and environmental review came into existence in stages 1, 2, 3, 4, 6 and 8. In stage 1, the safety review suggests potential safety hazards were to be identified. So, initial safety and environmental review, this is the legend for this colored box is the process, this is input, this is something deliverable, and this is arrow is showing path here. So, from the environmental and safety review process, the input to the environmental and safety review here, this process, input to this process is potential safety hazards and potential environmental targets. So, these were at stage 1 just identification. Then for safety hazards, minutes, list of potential issues and action plans were the deliverables that goes into the safety review, which were required in the stage 3. So, these then they help to develop the minutes of potential issues and actions, which help to get the safety environment review. This is a kind of a detailed review. This is initial review, initial, this is detailed. And how it is detailed? We have the final safety review required, we have the final environmental review required, which is based upon the guidelines or the minutes in the safety and guidelines for environmental targets and checklist in the environmental review. These acts as inputs to get the detailed safety environmental review, and they help to develop another list of the plans or the actual plans, and we get the final safety environmental review after inculcating a scorecard system. Scorecard system, it is the subjective importance identification system in which we get the what are the important attributes those we need to address in the environment review. Finally, safety lessons learned and environmental lessons learned were gotten at stage 8. Just to discuss this in short, this is allegedly produced by this author Fitzgerald, and they claim that this is going to be implemented by Black and Decker. Now, Black and Decker has safety reviews during stages 2, in stage 3, in stage 4 and stage 6. So, these are the safety reviews, and these safety reviews are the meetings that intended for reviewers to evaluate the assessment, action and process for design team in addressing product safety. Then the design for environment process adds an environmental review to the agenda of the safety review held during stages 2, 4 and 6. Here environmental review 2, 4 and 6, here environmental review comes into play. A separate environmental review is held during stage 3, which is not the part of safety review, which is not the common, and in also safety review the separate reviews are here. This is a separate review, this is a separate review. So, this is the way they tried to implement the design for environment, and when the design for environment process is first implemented, the design teams will have to fill out the environmental scorecard only during stage 6. So, scorecard is prepared here, that goes as input in stage 6. When the design teams become more familiar with the process, the scorecard will be completed 2 or more times during stage gate process in order to track decision changes that may influence the environmental metrics during the development process. So, let us try to see a few lines on this. The environmental reviews require design teams to review the checklist of key requirements and to consider guidelines for reducing environmental impact. This is general. When design for environmental process is first implemented, design teams will have to fill out environmental scorecard, as I just mentioned, only during stage 6 after the product design is complete. So, this product design is already complete and a scorecard for working on the requirements, what are the specific requirements of the scores of the different guidelines, that is filled in stage 6. So, doing this begins the process of recording environmental data and allows design teams to adapt gradually to the new process. So, this is essentially the implementation of design for environment in a scenario where it was not before. So, safety review was only there and DFE then came into the play, and then the teams have to understand both the things together. When design teams become more familiar with the process, the scorecard will be completed 2 or more times during the stage gate process in order to track design changes that affect environmental metrics during the development process. The design team will write a lessons learned summary during stage 8 to highlight innovative environmental design changes. What essentially is here, we will have to develop or write documents. These, what are these review? These are actually documents, initial environmental review, safety environmental review. These are the process, and the process documents are to be written. So, what are these documents? We will see in the next slides. And the lessons learned from summary will provide the innovation statement metric, safety review process and environmental review process run in parallel. We need to note that throughout this process, many other product development activities are occurring, causing changes to the product design. So, this is not only the safety and environment that is going on, many other things, availability, the difference between the schedule and the actual performance, all those things are going on. Safety and environment are added to the basic production plan here. Now, what are the documents those are needed to be prepared here? First is the product initiation document. Product initiation document is a document that this company Black & Decker uses to benchmark competitors, define performance targets and predict profitability and market share. So, it is initiation that from where or from which point the product has to start. It is this document that is mentioning this thing. The product initiation document will also address environmental regulations and trends and opportunities to create environmental advantage, as I said here. So, targets for environmental improvement will be included. So, this gives the targets for environmental improvement. Right. So, this is the output of this document. Then in environmental review, initial environmental review that was there in the initial stages, the first environmental review is coupled with a safety review. During this meeting, the design team should discuss current environmental regulations, design guidelines and environmental metrics. This is what he suggested. So, there is a meeting that is to be held in the stage 2, where we have the initial environmental review. Here we have initial environmental reviews in stage 2. This meeting discusses about the environmental regulation, design guidelines and environmental metrics. In the first environmental review, the list of regulations and design guidelines can be found in the guidelines and checklist document. So, guidelines and checklist document is prepared here in the first environmental review. Also, the environmental metrics are located in the environmental scorecard. Okay. Then the lessons are learned from the old documents, from the similar products, the previous year or the past data is taken, and past products are reviewed during this meeting to facilitate the environmental design ideas. The result of the meeting is an initial assessment plan. So, overall we have an initial assessment plan. The reliability representative will write the assessment plan, and the list of ideas are brainstormed for environmental improvement as we discussed in the value engineering or the creativity presentation. Next is second environmental review is held separately from safety hazard review. Now, safety is inculcated here in the initial document, but second environmental review is taken separate. So, during this meeting the project team will check compliance regulations, fill in the guidelines and checklist document, discuss the metrics in the scorecard, and review opportunities and additional environmental issues. If you have any questions on the scorecard etc., you can definitely read the paper published by Fitzgerald in 2007. So, it has details of the scorecard in which multiple inputs were there, multiple metrics are put in the scorecard. The metrics can be the total product or packaging volume or weight, then recyclability, disassembly rating, then flagged material or material used in the product, then maybe energy consumption, innovation statement, all those can be the metrics to conduct this environmental review. So, in this case the guidelines and checklist are updated. We get the updated guidelines and checklist document. Then reliability representative will update the guidelines and checklist document and write the minutes, and lead engineer will update the scorecard for the next meeting, and the next meeting is the third environmental review, which is coupled with the safety review again. During this meeting the project team should ensure that all environmental compliance issues are resolved. There should be no further changes to design due to environmental reasons after this meeting. So, this is the detailed design when we have got the input from the separate, this is separate environmental review and a separate safety review. Okay, detailed safety environmental review document is prepared now. So, the result of this meeting is an updated guidelines and checklist again than the previous one. So, we get the pre-final guidelines and checklist. Why it is pre-final? Because final phase has to come further. In the final phase or the fourth and the final environmental review, this is again coupled with a safety review. During this meeting all environmental compliance issues must be resolved. Optimally, no design changes due to environmental reasons would have been made between the last meeting and this meeting. The result of meeting is final guidelines and checklist document and meeting minutes. So, this is the final that is to be delivered. So, the reliability representative will now finalize the guidelines and checklist document. The lead engineer will now finalize the material declaration statement. This is material declaration statement. This is made by the lead engineer who has to work in production. After this, we have post launch. In post launch, what is there? We just need to see that what went well with the project, what didn't go well with the project, reasons why the product didn't meet the targets which were set in the trigger document. So, this is the post launch or the feedback document. The lessons learned summary will include the environmental design innovations which are realized during the product development process for the maybe publicity or for the customer questionnaires. So, these are helpful post launch things. So, an example of an item to be included in the lessons learned summary is a material selection decision. In this post launch, details should include what materials were considered and the rationale of the decision, the reason for the using the materials. So, lesson learned summary is very important part of the design for environment process because it provides the future design teams with the environmental knowledge gained by the previous engineers. So, there is a document known as feedback document, or it is also called as lessons learned summary. So, this is post launch. After that, we have feedback loop that has to run the completed guidelines and checklist documents and lessons learned summaries create a feedback loop of DFE process. So, this is a loop, that is a cycle that has to go on and on. The design engineers working on similar products can use this information to make better decisions immediately, and information is also valuable when next generation of the product is designed years down the road. The design engineer will record what environmental decisions were made and why they were made, the decision information, scorecards, comments on the guideline documents, checklist, all are archived here. Archive the documents. Now, in design for environment, I said the most important part is the life cycle assessment. In life cycle assessment, there are certain steps, and how do we conduct? The first step is we define the goal and scope of the assessment, at what we are going to do. Right? In defining, next step is the life cycle inventory. This is also known as LCI. Third step is we now conduct the life cycle impact. Impact assessment. This is known as LCA in a way. And finally, we have the interpretation of the results. Right. So, in the first step we define the scope. Scope can be whether it is a product or component or the whole system, or maybe for the whole economy we are thinking of what is the total global issue, regional issue, product wise, micro, meso, macro that I discussed in the previous lecture. Then life cycle inventory analysis is nothing but this is actually data collection only. Okay, life cycle impact analysis, the results of the LCI or the life cycle inventory analysis are transformed into environmental impacts, then weights are given to them. In interpretation of results, we identify the most important environmental impact and limits and uncertainties for that. So, these things are conducted here. For goal and scope, the life cycle assessment models a product, service or system life cycle. So, we actually trying to build a model that what will happen in reality. So, this model is simplification of the reality, and as with all models that it tries to simplify, and that happens in simulation as well, they are distorted in some way. The challenge for a good life cycle assessment practitioner is to develop the model in such a way that the simplifications which are made and the distortions do not influence the result too much. The best way to do it is to define carefully what is the scope of the product. Scope can be either micro, meso and macro scales that I just mentioned. Okay, I can either put whether it is micro, meso or macro scale. Okay. The scope can be whether we are working or till what level of use are we going on, whether it is before use, during use, after use. Most of the times the life cycle assessment when we are doing most of the softwares do it for the before use part. The before use is from the extraction of the ore to the final delivery to the customer. The goal can even be defined like in life cycle, like in EIOLCA, economic input output life cycle assessment, that we'll just discuss. The online tool is there. There are two kinds of prices there: purchaser's price and producer price. Purchaser price is that when purchaser is purchasing that means after production, after this factory, the work is there before use. After the production, from the production point to the customer point is delivery. Transport is also included. So, this can be a scope like till manufacturing and transportation it reaches customer. Scope can even be the producer's price, that is just while production at this point it is limited, transportation is not included. So, that scope has to be defined very clearly when we have to start the life cycle assessment. So, this is point number 1. Also in defining the scope, we need to say whether it is a screening life cycle analysis. What kind of life cycle analysis? It is just screening or just the assessment, or it is comparative, that whether we are comparing two different products, or it is a complete product and mitigating results with that, or do we also need to put the causes of that? I can put causal or the reasons. So, it can be external or internal, certain review verifications can be there. So, this is defining goal and the scope. So, in the goal and scope also we need to know who is the intended audience, what are the primary intentions, who are the involved parties. So, definition of product system, what is definition of the function or functional unit that we are considering, and all these points need to be addressed here. There are certain questions that need to be answered. What is the reason of carrying out the study? That is why I am putting the causal, we need to put on that. Then what is the intended application, what to analyze and how to analyze. Yeah, this is important. What and how, this is important. Why it's okay, because we need to know the life cycle assessment, that is okay, but these are important questions here. Next comes the life cycle inventory analysis, that is essentially the collection of data, and along with collection of data we have data collection and data modeling. And modeling is actually the putting the data in the form of information here. It is not a complete modeling, however, this whole life cycle assessment, this whole is a complete model in itself. This is just actually fetching information. Then the results here can be inventory table, extensive list of environmental interventions, those are there. Then these things are there in the step number 2, where we look at the environmental inputs and outputs. I would put inputs and outputs, so which are associated with a product or service, such as the raw materials, energy, emission, pollutants, total pollution, waste streams. So, this is where we get the complete picture that what is the status. We have just defined the goal and scope in the first step, and here we get the overall view that what is there. Now, we need to conduct the third point, that is life cycle impact analysis. In life cycle impact analysis, we draw the conclusions that allow to make better business decisions. We classify the environmental impacts, evaluate them by what is important to the company or to the economy that we are talking about, and we need to translate them to environmental themes such as global warming, human health. So, those are the broad terms: global warming, health hazards. Okay, we need to quantify them in this way. In the third step, we need to actually determine the environmental impact of the reference flows. There are certain flows. Flows of what? Materials, energy, and we have emissions, those are there. In this case, actually we are translating the inventory table. We get a inventory table here, inventory table. This is now translated into a impact indicator. Impact indicator of the results. Right, but this is not the end. Now, we need to interpret the results as well. While interpreting the results, which is the last step, the conclusions are well established. The conclusions are to be made. The ISO standards describe a number of checks to test whether the conclusions are adequately supported by the data or by the procedures which are used. So, in this way, one can share one's results and improvement decisions with the world without any surprises. So, the conclusions are to be made, and certain checks like consistency check, okay, then completeness check, that whether it is complete or not, or we need to identify the gaps. Then we need to see this sensitivity analysis. Sensitivity analysis, that whatever we have conducted study on the specific set of the data, is it replicable, or is it possible to produce some general conclusion out of that or not, or within our limits what we can put here. So, next is finally we put conclusions. If we take off the conclusions from here and just consider these three parameters, so people have even defined it in a way that the interpretation of results go hand in hand with the first three steps. For instance, this is step 1, 2 and 3. Step 1 is defining the goal, step 2 is life cycle inventory, then this is life cycle impact analysis. The fourth step is here, that is interpretation of results, that go hand in hand. At each step we need to interpret, or we need to see that whether whatever we have got, we have got the information, we define the scope or goal, whether it is good or not, or whether it is acceptable to our work according to the boundary that we are designing or not. So, life cycle assessment helps to have insights in the environmental impact. The company's clients or investors want insights in the environmental impact of the products or the production process, then cost reduction happens. So, let us read a few lines on life cycle assessment. So, this is some information about the life cycle assessment. Now, individuals and institutions that are contemplating lending money to a startup company look for sources and uses worksheet, because it is an excellent summary of the startup's financial plan. In a similar manner, life cycle assessment can be viewed as a sources and uses statement, because the customers are demanding the green products these days. So, these insights in the environmental impact, one's clients and investors would like to have insights, the customer would like to see the products or production process in a way. So, that is important. So, most life cycle assessments include a comprehensive listing of inputs and the resources. The output defines how effective the facility is in converting these resources into products while minimizing waste. This is important. This is an example of the material flow in life cycle assessment, that how production of steel and finally we get the goods, we use them and that is recycled. This is the material flow, the same thing that I showed you in the block diagram, how recycling, remanufacturing and reuse happens. Reuse is not here, but recycling is essentially here. This is actually extraction of the ore, which was the first step. From extraction of ore, first is we get pig iron. This pig iron is then helps to produce steel here. We get steel here in third step. This is step 1, this is step 2, this is step 3. We get steel in step 3. This is the product of step 3. This I can put step 4, finally get the product. Step 5 is we send the product after the service life to scrap, and from that this recycling scrap is again taken. This is step 6, that again goes as an input to step 3. Now, we can see something here. This is, as I said, industrial symbiosis. In industrial symbiosis, what happened? This is, I can say, not a step. This is a step, I would say 2A. Okay, this is 3A. In 2A, what happens? The cement is produced. Let us try to see these steps to see an example in steel manufacturing for life cycle material flow. So, this is taken from the reference here. So, iron ore and coal extraction is there. First, pig iron is produced. The first step in the steel production process is the fabrication of pig iron or hot metal through smelting iron. This is a blast furnace from which lime is an essential ingredient that acts as a fluxing agent to facilitate the formation of low viscosity slag and absorption of impurities such as silicon, aluminum, sulfur and so on. This slag can be used to produce cement. This slag comes here, this helps to produce cement here. So, different slags containing lime of an integrated steel plant from iron ore to steel are further used to produce cement to construct roads. From here, the next step come here is the steel making. Steel making also produce slag, which also goes here. So, this is an example of industrial symbiosis. Different slags containing lime of an integrated steel plant from iron ore or steel are further used to produce cement. This is from iron ore, this is from steel, from step 2 and step 3. This is step 2A. So, this is step 3A where we get the steel that is ready. In steel making, what happens? The liquid pig iron scrap is refined into converter to liquid crude steel. For this purpose, again lime is an essential fluxing agent to form a good slag and to remove further undesired elements. Next is, after this step 3 and 3A, step 4 is the final use. The usage of steel. Steel is an essential material in automotive industry and the production of consumer goods. These are home appliances, production of automobile. The car is being shown here. They are used in producing washing machines and of course in building and construction. So, this is a use of the steel. After the use, we go to step 5. Step 5 is recycling. We are not considering reuse here, that is a step in between. I can put step 4A is reuse, okay, or 4B can be remanufacture. Now, step 5 is when it goes for recycling, and after recycling it goes as a scrap, recycling scrap as a raw material to produce new steel. Electric arc furnace, that is a more modern technique of producing steel, allows for using up to 100% of scrap when producing new steel, which saves both energy and raw materials. Lime is added as fluxing agent to produce basic slag with low viscosity to absorb impurities. So, this is the material flow specifically in the steel manufacturing that is taken as an example to illustrate that how the flow from the extraction of the ore goes to the customer, then it again comes back to the manufacturing of the steel itself. So, this is one of the examples. Now, this is a study that is taken by Ginley in 1994, and it is well cited by many people. In this case, they conducted life cycle assessment in a way that the raw material that is collected by weight of the raw material, and the final that goes to landfill. What is the weight that goes to landfill? So, in that way they take, okay, this is a material collection, and what is the, at each stage there is some loss. When material collection is there, material collection, it is in a way extraction of ore, there is some loss. Okay. In material processing, that is when manufacturing, there is some loss. This loss is again in the weight. During production or fabrication, there is some loss. This is the manufacturing of automobile, some loss, and in this case some recyclability is also there. After this, the product use is there, after use also there is some recyclability that goes here. Okay. At each stage there is some loss, and in reuse also some weight is reduced and waste is also produced here. So, this is disposal, this is where the final landfill goes, that is the final waste of, that is of no use, but it can also be recycled for other uses. Recycle is taken here in this case. So, they have made this assessment for different materials. This is steel, plastics, miscellaneous, and all materials. Okay, this is actually for all materials, and this is if this I put this as 1, 2 and 3, this is 1 plus 2 plus 3, all materials is like this. So, what is actually going on here? An automobile is dismantled. The specific materials, steel, plastics and other materials are taken separate. The total weight that is taken while manufacturing the automobile and the losses that happens, those are studied, and finally what is the weight that goes to the landfill, that is taken care. This is one of the way of the life cycle assessment that they did in 1994, that is around 25 years ago. So, the total weight of the automobile was 1366 kgs. Okay, I can put it is around 1.366 ton. So, this is the total weight. The total loss in material extraction or the extraction of ore is 128 kg, and the material that goes for material processing is this. Actually, how it is taken? First, the total raw material that is extracted is taken, and total material that goes for processing is taken. This difference, this 128 is 1366 minus 1238. This is equal to 128. This weight comes here, the loss, and after this, and around 1200 kgs of material goes for actual fabrication, where actual fabrication happen, and the weight for the product that is used by the customer, the weight of the product, that is the car that is delivered to the customer, is around 1.239 tons. Okay. So, while using and reusing 80 kg is consumed, in waste is around 62 kg. The total disposal weight is 987 kg, of which 763 kg is again recycled, and in the first run 224 kg goes to landfill. This is the total weight. This is the separate weight for steel, plastic and miscellaneous. Now, what one can interpret from this? The percentage is weight. The total is the total percentage of steel that is consumed. What is the total percentage of plastic that is consumed, and the environmental impact of these specific materials that can be taken into account. So, what is the material? This can be normalized on the basis of percentages, and the comparative statements can be made depending upon what is the carbon emissions, total greenhouse gases emissions that happens during manufacturing, before manufacturing. So, all these things are considered here. So, this is one of the way or one of the studies on life cycle assessment that is taken by this researcher. Moving on, the origins of life cycle analysis probably came from the environmental impact studies and energy audits that were carried out in late 1960s and early 1970s. These studies attempted to assess the resource costs and environmental implications of the industrial practices going on in the world at that time, and it started way back in 1960s, and we have seen one study in 1994. To be of value, the analysis needs to identify and quantify the source and amount of waste generated over the entire manufacturing sequence. This is similar to a procedure that financial managers call sources and uses. Large publicly traded companies will include a sources and uses of funds statement in their annual reports. The resource in this case is money, where it is obtained, its source, and how is used to carry out activities of the business. In the similar way, life cycle assessment, in this case the inputs include raw materials, stocks, resources that are used for the creation of the product. Resources include energy demand here, electricity, gas, oil, coal, etc., and water. In some special instances, land use might be included. While land is not considered as a consumable in the creation of a stock or product, there could be a circumstance that would make the land unusable for a period of time. That is why the land can also be considered as one of the resource. So, each of the 7 major activities in manufacturing sequence, from the very extraction of the ore to the final delivery to the customer, these activities offer opportunities for creating value and waste. The table in the next slide lists these opportunities along with their potential for creating waste. This potential will vary for each of the 7 steps. For instance, an assembly operation may generate some waste, but generally the environmental impact will be minimal. In assembly, there is not much energy used, there is not much pollution produced. So, the environmental impact is minimal here, but waste is there. However, in some of the other steps, the waste and environmental cost can be quite high. As an example, for extraction of raw material, a large part of waste will be environmental costs. So, this is given in this table here. This is again taken from a study. The potential for creating waste compared with the value added potential for each step in the generalized manufacturing sequence. So, this is step 1, 2, 3, 4, 5, 6 and 7. This is extraction of raw material. The potential of creating waste is high. The potential of adding value is moderate. It is not adding value. Adding value, in a way, it is telling that adding value in the terms of from the viewpoint of the customer. Adding value in a way means the total value that customer perceives. Customer wants the automobile to be manufactured, they want automobile to be ergonomically right, aesthetically looking good, working properly, giving good performance. These are the functions that customers need. In that, extraction of ore, yes, it is adding some value, it is not low, but because the material is there, but it is not even high. Now, create stocks from the extraction of materials. The potential of creating waste is moderate to high, and potential of adding value is moderate. Manufacturing process, this is actually manufacturing, this is before manufacturing, this is after manufacturing, okay. And specifically this is after use, this is during use, and this is before use. I will put it, this is before use, this is during use, this is after use. Now, you can see in assembly operations there is a moderate waste, but low to moderate value is added. In distribution, the waste is low and the potential value added is also low. In disposal, the waste is very high and the potential value added is low in the product. So, this is the generalized manufacturing sequence and the potential of the creation of waste and adding value, which are compared. Now, in this, balancing the potential for waste against the potential for adding value has been a manufacturing tactic for years. Now, the changes in technology is coming, knowledge management, these things are coming, which requires to reorder the balance between the value added and the waste generated at a particular step. So, the company that limit itself to only one step, for instance, the company would like to limit itself to only manufacturing processes, or for instance, if a company would like to limit itself to only assembly operations. So, that would be in theory be simplifying its business by focusing on just that function, but this limits the company to calculate the total value added in this step. Alternative to this, manufacturers should try to do all these 7 steps at least for life cycle assessment. Maybe they are not in this business, but at least for life cycle assessment, in order to earn the value added potential from the raw material to the sale and disposal of the product. So, this has to be the approach in the present demand that is coming for the green products. Also, the company would have to develop the skill and expertise for all aspects of manufacturing sequence, that is also required. So, just to recapitulate, we have seen in this presentation why product design for environment is necessary, what are the stages and importance of design for environment, which issues comes under the scope of environment. We have seen the scope in these 2-3 lectures. We have seen what is design for environment, we have seen how to implement design for environment, we have seen the levels of design, we have seen the levels of design for environment. Then we have taken one study on implementation of DFE, or one of the approaches that was taken by a researcher. Then what are the main sources of waste that we have seen. Then we saw what is life cycle analysis, and more than that we saw what is life cycle assessment. After this, I like to discuss the software tools. One is an online tool, that is EIOLCA, Economic Input Output Lifecycle Assessment, that we will just take in the next lecture. After that I will discuss Gabi tool, which I said I will just tell you what are the various softwares available, open source and the licensed versions, and what are the softwares on that you can just get in an open source and work on. So, we will see and try to see the examples that what is life cycle assessment and what are the results those come and how to interpret those results. Thank you.